Good morning. Perhaps we could gradually start. I hope you have had a bit more sleep than I did last night. So hope you're doing fine and thanks for coming. My name is Pekka Manninen. I work at the Finnish Supercomputing Center CSC as a director in charge of our leadership computing facility, and also have a position at the University of Helsinki. Well, my academic background is in computational physics/theoretical physics. Got my PhD 15 years ago. That was like 15, not 50. Did few postdocs, and after establishing my own research group in the University of Helsinki, I realized that I was more interested in the computers and the programming than the problems that I was using the computers for, and hence moved on to the service provider side and joined CSC a couple of years ago already. And basically done my career in supercomputers, working also for a supercomputer vendor for a couple of years. But that's enough about me. So what we're going to do today is talk about supercomputers, the biggest computers on a planet. So talking about the systems, past, present, and future. What do we really do with these machines? So why do we install those? And also the second theme is AI, so artificial intelligence. So what it is in reality today, and what does it mean, and what in practice. But well, we are in a role-playing event, so the most important part will be to forget the sort of boring details of reality and discuss how these themes could be employed in fiction as story elements. So as a fiction, and especially in role-playing games. So what I'm asking you is to reflect the stuff on the first two parts. What would you do, or how have you been using this, or if you have seen really nice pieces of fiction or clever usage of them in ready-made campaigns or scenarios, and present them towards the end. So I will be talking first, and then I'll give the floor to the audience for the last part. And of course, if you have any questions, comments, feel free to interrupt and ask. So we'll have plenty of time. So I will keep the time such that we have time for the last part, but feel free to interrupt and ask if you want to have any clarification or further information on any things. And last thing is that I'm just stealing the slide template of my employer, but I'm just presenting it as a private person and a fellow geek here, and some things are a bit opinionated here, but those are my own and not those of CSC. And what comes to role-playing games, I started by getting the Finnish RuneQuest as a Christmas present in 1988. So there haven't been many weeks since then that I haven't been playing something every week. Okay, the first part, so supercomputers, the big humming systems. So why and how? The science as something we establish understanding of surroundings, our surroundings, the universe we are living in, is progressing by an interplay of three pillars, I would say. So we need to make models, we need to make theories on how things could be done, and typically put in terms of mathematics, in the language of mathematics. We build experiments, run experiments in order to verify these theories. But the third pillar is that in practice, no field of science is able to do just like this kind of paper and pen work anymore, but everything needs to be simulated, everything needs to be analyzed with extreme number crunching power, and also also the computational simulations can provide new insight, new phenomena that we want to either test with experiments or sort of formulate as a more solid theory if we found something on the simulation. So that's how it works. It looks a bit like physics at the moment, but of course it's up. You could replace with molecular biology lab and or whatever experimental facility there is. But this is a way we establish information and understanding insight on the physical reality around us. And for the last pillar, so the computing ones, it's been the driver for making more and more powerful number crunching machines, because every single science domain, there is some data analysis problems and or simulation problems that cannot be computed with any given device on existing at that very moment. So there's always something beyond defense that we cannot solve, and that it gives a good reason for building ever more powerful computers. So the computers are the supercomputers are the kind of the fastest computers on the world. So there's no clear definition, and some kind of a de facto definition is that if it enters to the top 500 list, is something that people consider as a supercomputer, implying or implicitly implying that there's limited number of supercomputers in the world at the time. So it's some kind of a definition, not a very accurate one, but nonetheless. And one thing is to notice that they are scientific instruments, not perhaps computers per se that much, but scientific instruments that are built on pretty much the same compounds as like off-the-shelf or commodity pieces. And one CPU processor is not that much faster than on a laptop, but the idea is that just like put many of them to the same place, tightly connect them tightly, and make them work together, and that builds a supercomputer. And why do we use it? Is that, like I said, there's always been and likely there will be challenges in important scientific disciplines that cannot be solved with any given system on the existing at the moment. And we can use it for take a model system of something. We have some governing equations that describes this system, and then we develop it in time. So what happens on the next time step. This is known as simulation. So for instance, weather forecasts is something that everybody hit on a daily basis. So we know exactly the couple of partial differential equations that govern weather as a phenomena. We just need to put them in a grid and simulate this from a observation. So what was the weather, and then we compute it further and make a forecast of the weather. And the same can be used for the systems. Can be molecules, they can be materials, they can be fluids, they can be solids, whatever. We just know the equations that govern it, and then we simulate it, how it develops in time. Also, we need the extreme number crunching power for getting insight out of big amounts of data from telescopes, particle accelerators. We can data mine the social media or the big data facilities, so what people do in Facebook or Twitter and so on. And more we need it for the AI part. And basically, as I'm going to discuss in a minute, the AI the kind of a deluge of AI over the last 3 years is a really outcome of so that we finally managed to put these two groups of people to talk to each other. So the supercomputer people and AI people started to use their same methods, and suddenly we have kind of a whole new world in front of us. And so this, like I said, it's been driving the development over the course of years, and it's kind of a Formula One of computers. So there's technologies that need to be built for the supercomputers, and they kind of fall back to the community like solid state disks have been around in the supercomputers from the early 90s and so on. And so the history of supercomputing is something, or the purpose of the supercomputing over the ages is something that it starts from the post-war military purposes. So starting from crypto or breaking the codes of the hostile countries to modeling the first nuclear weapons is the really why did these machines evolve. But it was suddenly quite from the beginning evident that this will be having something on the scientific or the non-military part as well. So physicists, mathematicians, chemists took these machines into their own usage pretty early on. Also, banks, insurances, also this kind of an commercial usage started to appear already from the prehistory of the mainframes and big computers. And as we go more domains in scientific parts, military or applications start to raise in the all kind of fields, and also when approaching today, pretty much all fields of science have found some use for the largest computers. Military people are doing well. What military people are doing, we have not that much view on what they really do on the US. Nonetheless, they do own some of the biggest systems on the planet. So definitely they do stuff with the largest installations still. And also, of course, we can find more and more commercial or kind of this kind of business-oriented usage for the biggest simulation. And the trending things today in this decade have been really kind of big complex system modeling, trying to simulate human brain from bottom-up direction, understanding full organs as a chemical systems. So doing so big molecular dynamic simulations that we get the full cell, for instance, as just a chemistry. And also of course, search engines, deep learning, so image recognition is something that we are heavily driving the field at the moment. Any questions, comments so far? Yeah, sure.
Has the ethics of supercomputing changed since Cambridge, Facebook scandals, stuff like that, about people's private data, accessing it, processing it?
I think they are a bit too recent for having really changed much. Of course, we have got the GDPR style regulations that everybody need to comply, and we have found technical solutions for dealing sensitive data. But I don't think really the hyperscalers haven't changed anything on they just they as evil as they used to be. So I don't think they changed anything. So it's their business. So I mean, they build multi-billion machine halls, and that's what they own. That's the understanding on human behavior and the individual behavior is the IP, and not your cat pictures or anything. It's really the understanding. So of course it's their core business. They won't be giving it up. So that's my pretty feeling about Facebook and Google. Okay, so the prehistory of computers, like I said, so the start dates back to the Cold War style. So the biggest and most expensive computer ever built is called Sage, semi-automatic something, ground something, can't remember. But it was meant for monitoring the whole US airspace for Russian missiles and bombers. So if you've seen the Dr. Strangelove movie, that thing really existed. So these kind of big control rooms really existed, and it was by far, by footprint, by terms of weight, by terms of investment money, that was the biggest computer ever built. It is sort of separated over 22 sites of each of one house of this kind of equipment, and so it's hard to assess the computational power of this system. It's probably something that fits on a laptop nowadays, but anyway, so it was a huge effort on building this one. So clearly, the field has its roots on the military very much. And like I said, so the first academic something that was really labeled as a supercomputer was called Atlas. It was in England in the early 60s. And more and more this installation. So the first supercomputer in Finland was the UNIVAC system in 71 installed, and then when CSC was established to host this system. And when progressing the 80s towards 80s, so there was this iconic gray machines of these vector machines dominating or kind of defining what is a supercomputer. And the modern era of supercomputers starts from the top 500 list, where the systematic computational power measurement starts from the 93. And it's a very accurate realization of Moore's law. So it's a logarithmic scale. So this is a straight line is an exponential growth. So we see that the number 500 as well as the sum of these systems have been very, very flat line until the most recent days in the world from the early 90s. Currently, so as of today, so the last list is from the June. The fastest system on a planet is called Summit. It's in Oak Ridge National Lab in Tennessee. It's capable of doing 125 petaflops per second, meaning flop means a floating point operation, so one addition or multiplication, or combination of them. But like one number plus a number style operation. So it means that the number starts with one, and it has 17 zeros after it. So that's in 1 second how many computations it can do in a second. On this logarithmic scale, the top-end laptops like the latest MacBook Pro would hit somewhere in the 250 gigaflops, meaning implying that the fastest computer in the world in the mid-90s was in the same regime as one laptop today. So there's a one take-home message for computers or for role-playing games is that the supercomputing power goes mobile in terms of, say, a bit more than 20 years. So the computational power or the capabilities what Summit can do today is something if you run your near future cyberpunk things. So if you look at the 80s the technology projections of the say cyberpunk 2020, they are a bit lame for what happened reality here. But I think just like if you want the project for 20 years from now, take the kind of the current state of the art and make it mobile. Also, your cell phone would be on the top 500 list somewhere. Would have been on the top 500 list still in the late 90s. So that's the technology development here. In Finland, the fastest computer in Finland is called Mahti. It's currently being built in our data center in Kajani. It's going to be followed by it's called Puhti and Mahti compounded is coming later this year. So it's going to reach some 8 petaflops in terms of the lean-back performance. So this is not exactly the peak performance, but it's a benchmark called lean-back, means a given task to solve. And just the glimpse of the near future show what is coming up, and of course to show off. So one of the largest machines installed next year is called Lumi. It's going to be installed in Kajani. So it's not a Finnish system, but it's a pan-European system funded by the European Commission and 9 countries, including Finland. It's faster than Summit, so it's a 150 petaflop in lean-back. Let's see if the Chinese pre-exascale system or the US Aura can make it before this one if they don't, it will be the fastest in the world. But anyway, it will be somewhere in the top 3 systems. So it's in an old paper mill in by the Oulujärvi in Kajaani.
Why are you in Kajaani? Why is it
Because of the paper mill, it's an kind of it's an unparalleled place for hosting supercomputers. It has paper machine used to consume like 200 megawatts of energy, so we can easily run these 10 megawatt systems on the.
Is there also a data link in Kajaani, which is better than in Helsinki?
So the data connection.
Yeah.
So it's a part of this academic backbone. So FUNET.
Yeah,
So that's an basically the internet connection is it's comparable of having it in Aalto or Kumpula or somewhere, just because it's just part of the internet backbone data set. So because I had this graphics. So what is a big system? So the Lumi system will be pretty much on the size of a basketball field, 450 square meters. The floating point capability is something like if you compare it to the MacBook Pros, it's like a stack of 9 kilometers high of MacBook Pros. Of course, you cannot. The 600,000 MacBook Pros can't do the same stuff as this thing is doing, and vice versa. But I just to give an idea on the, and also it's able to read from a hard disk to a memory on a 1 terabyte per second, meaning that's like a 20,000 streams of full HD movies, and this kind of a data moving capabilities. The networking is the bisection bandwidth, so meaning sending data from another half of the machine to another one is way much more than the whole internet can do at the moment, and so on. So there's more data moving on the machine than in the whole internet, for instance. Okay. Also, the trends when it comes to technology is that we're going to see more of the same. So new memory technologies, processor technologies, new accelerators, and so on. But perhaps more specialized systems coming for like on a purpose. But of course, we're going to see these tip of an iceberg systems coming up, but also for more and more like different communities are building their own systems for a single purpose. There will be, Intel is looking at something called, and more disruptive things include, Intel is looking something called Neuromorphic Computing. It's like a chip of very low power, very low capability chips, like a cores, doing in some kind of a in-sync fashion of communication. I don't fully understand it. I think it's bullshit, but I mean, I'm probably wrong, and Intel is probably right. But so because they are really investing, but I don't really get the concept of this. And also, quantum computing is a kind of a new world. So we've been stuck with semiconductors for decades now. So there's and there has been this promise of doing instead of classical electrostatics and dynamics, we want to do quantum mechanics to use the world of the strange and beautiful world of quantum mechanics, like superpositions, tunnelings, entanglements, and so on, for getting like a do computation and speed up computation. So there's different technologies that can do it, and there are already commercial products out of on the market, like the D-Wave quantum annealer. So basically, you can go already and buy a quantum computer. So it's not science fiction, but it's there, and it's already commercial something. You can go and buy a quantum computer if you like, and if you have a surplus money. But this won't be replacing the need of traditional computers or supercomputers. So, but it may be, and as an accelerator, it can be a game changer for many things like combinatorics or like cryptography and cybersecurity, and also simulating systems like quantum simulation. This is something that we going to see quantum computers to have a major things in the upcoming years. Yeah,
Can
sure.
I ask?
Yeah, sure.
So what's like the computational capability of the commercial quantum computers?
So it's the funny thing is it's a so different world that it's difficult to compare them. So basically, it's able to do one flop. It's able to do one operation on the cycle, whereas these systems were doing the billion operations per second. But the idea is that the one operation is not a summation or anything. It's a kind of solving the whole optimization problem. So basically, it's a solving one full optimization problem in one cycle. So it's a very difficult to compare. So this one cycle can solve something that cannot be can take a very long time in a normal computer. So, for instance, the easiest one for this D-wave annealer is an quantum spin system, and there you can see like a 10 million fold speed up from the quantum computer as compared to just running it on a computer. But if you try to do a summation with this machine, so you try to add up two numbers, you have to cast this as an optimization problem and do like a shitloads of stuff in order to do a one single summation with this machine. So it's a kind of a new world of thinking things. So nothing basically we know. We have to throw away everything we know about computer programming in order to use these systems. Okay, the first part was just some thoughts here. Is that the scientific research and the fastest computers have been working together, so there haven't been not the progress in science or the computers without each another. And still there's use cases for almost all fields that are driving the building ever more bigger systems. And the current systems are capable of doing this 1 and 17 zeros operations per second. And like I said, this comes from a big amount of this kind of close to a community hardware just made to work together. Any further questions or further information or any comments or anything on this part?
Coming back to quantum computers, so if they are highly specialized uses for those, so in the end you would in any way have a traditional supercomputer next to it or
Yes. Yes.
So your salary is still secure.
I've been looking at quantum computers for 15 years now. So if somebody takes away the supercomputers, I can move into quantum computing. So my salary is secured, yes. But yes, that's true. So there will be problems that won't fit on a quantum computer. A lot of them. So there will be very few problems that can be easily cast on a quantum computer. So there will be need for classical computers for basically always, and it's gonna be also for those problems that are good for quantum computers is probably some kind of a hybrid model where you combine both of them for a single problem. Anything else? I'm doing the time was pretty nicely. Yes. Okay. The next topic was the AI. So I've been giving the same talk 5 years ago in not the same talk, but a similar talk in Ropecon 5 years ago, and basically there was we discussed AI as a concept and a story element, but that has had nothing to do with the AI as I'm talking about now. So this is a very recent thing that just happened. It came out of the blue for many. What has happened over the course of last 3 years or so in AI. And AI is not a single technology, or not even a technology. So it's just like a denominator for a large class of problem domains. So including machine learning, natural language processing, all kinds of intelligent systems, doing speech recognition, machine vision, robotics, and so on. And I would define it. It's an implementing capabilities that resemble somehow intelligence, human intelligence. Well, it's a kind of an half joke. Is if you have a problem or piece of software, if it's written in Python, it's likely machine learning, and if it's written in PowerPoint, it's AI. So it's an kind of what do the politics love, and it's very easy to get funding for projects or new computer installations or whatnot if you just have the magic word of AI in anything nowadays. But so vast class of different kind of methods, different kind of implementations under one umbrella. That's the purpose is build something that resembles a human. And a kind of the bar, what is considered as intelligent is of course increases. It's some kind of a direction somewhere. Because I mean, if you compare in computer games, the AI, from Pac-Man, where it's just like a had if else on the direction where this ghosts were moving towards the Pac-Man. That was kind of an AI in the 80s. And nowadays, computer AIs need to do much more clever things in kind of state-of-the-art computer games. So kind of what we feel, observe or experience as intelligence is kind of what matters, and then what is an intelligent and artificial intelligent. And like I mentioned, is the why this is so hyped and why there's kind of a deluge of things. Well, it's not just hype. I mean, there are incredible things have been happening over the last couple of years in terms of just everyday life in our we may pay attention or even may not pay attention on things that we observe in our mobile phones and how we use computers and so on. And it's basically what happens is that the methods are pretty old, so they may be dating back to the 90s or something. But just like somebody just like put enough data and enough computational power combined with these old methods, and suddenly we start to get sense out of these methods. So meaning the machine learning methods. I try to briefly explain what is machine learning in its heart. So it's an way of finding a mapping between a data set to another. So we have some data, and we want to find a description that converts it into another piece of data. So the simplest thing is an, of course, function of an, or you can think this mapping as most simple thing is some functions. So you feed in values of x and get the values of y, but of course this can be much more hairy data. So you can find correlations from people's shoe size or something, and that then compared to the height. Okay, find a correlation of this, and the could be some other human characteristic on the y side. And so we have some data on x. And then we have this kind of something we call neurons. So they're just like mathematical operations. They take in multiple input values and give one value. And these neurons are typically organized in layers. So we have the input layer, a number of hidden layers, something that happens, and then we have the output layer, so the data y. And the idea is to have many of these layers, different operations doing different things, and then weights on these. So we can this kind of knobs on the so we can fine-tune this network, so given different weights for different operations. So we basically define these connections, and we define these operations, and then we weight it on as long as we get sense out of this, as long as the y is accurate enough that we want it. So we have some samples of y, and we have some input of data. So we train this network as long as we get sense out of the data. And once this network is trained, so we have plenty of these neurons with their weights and their operations, we can employ this as this kind of using inference, meaning that we then produce this data y. from data X. And we see it in everyday life in a very incredible achievements. So, for instance, machine translation is a very close to a human, like a professional translator capabilities between many languages at the moment. And especially the Google's beta version is well, the previous Google Translator was based on data analysis, so it tried to find phrases from big pieces of data. Now it's an trained neural network that makes the translation. And basically, if you look at the what did the training do is that the neural network developed its own lingua franca, so it translates everything into a Google or its own language, and then translates it to the next language. So these kind of things happen just without our control for these hidden layers in the neural network. Voice generation is a very close to a native or kind of a human. It's hard to recognize in many languages like English and Chinese the AI generated voice, because it can add this kind of human breaths and pauses and so on. Speech to text is better than transliterating on a human level. Lip reading is outperforming humans. Computer vision, reading text from images, those have been improving a lot. Self-driving vehicles, cars, ships, and so on. Those have been making tremendous progress recently. You can see this in the personal assistants. So I'm surprised how well this can understand even Finnish. So just like I don't own an iPhone, but just like heard it yesterday and demo what can Siri do in a Finnish language, and it's a very very untrivial of implementing this kind of things as the personal assistants. So the Amazon Alexa, Google Assistant, and so on. The social media network. So how does it know that I may know this person? So this is of course also a very very highly trained network on understanding human patterns and how humans interact and so on. Well, my MD friends may disagree, but also there's a lot of good things for healthcare in image recognition on analyzing radiology images. Making new drugs and so on for just from the applying machine learning techniques, and also, of course recommending the online marketing and sales. So recommending just the right products for you.
What's your opinion on these tech giants having certain opinions and then basically using these translators and social media networks, personal assistants to drive those agendas by, for example, making these assistants unable to say certain words or hear certain words?
I think it's a bloody scary world. So I mean, of course, if you combine this with, I mean, China is one of the leading countries in AI, employing all this, but with government directed fashion. So they have this lot of like a face recognition everywhere, gathering intelligence basically everywhere in the just like a open cities, combining them all the social media behavior and so on. So I mean it's something that any of the dystopian fiction from the 80s or 90s never could dream of how much we have given up our privacy and ourselves for the tech giants, just believing the Google slogan of "Don't be evil." So I mean, even if they're American, it doesn't mean that they wouldn't be. Well, probably the purposes are not sinister per se, but everything is for sale. So it's and also, of course, it's well, like we can, gonna be part of the discussion, but I can take it now. So, of course, the networks these are just like a computer algorithms. So everything is dependent on the data over here. So there's a nice examples on how people turned the Microsoft Twitter AI Twitter bot into a racist by feeding like a racist and a white supremacy tweets today. So they because there's a reinforcement learning, so it kind of learned on the go. So it was trained all the time by Twitter. What did people talk to? So people find it out and started bouncing this Microsoft Twitter bot with all kind of white supremacist things. So it started making its own opinions, so that they had to turn it off. So I mean it can be replicated on a many fashions. So there's a lot of algorithms used for kind of like finding good job candidates, but using it as an assistant for job interviews. And it turned out that, in fact, because you feed it with a kind of existing data. So basically, you feed in all the kind of opinions of these people who have been doing the recruitments before. So it's really it just takes in the same data as we put to the network.
Yeah, I was thinking about what you said earlier about the development of computational power, and that in 20 years we have same power in our cell phones. So could it mean that if they are not careful and they give us the computational power, then we can get the power back, so to speak? I mean, could it be that since now training these AIs is so expensive, it takes time, so the data is valuable. But if the computational power increases very fast, then the value of the data goes down because you can do it in your cell phone.
Yep.
So it would be like
assuming that we are fixed in terms of generated data and that the hyperscalers won't produce any better machines.
Yeah.
So if they could stock of today, yes, but probably they won't. So I mean, the people are like putting in there more and more their pictures, more and more everything. So that's the fee. That's the kind of a business on how do these networks are being trained. So of course this, and also it works in two directions. Meaning that okay, so why do I need to bother of programming a supercomputer if I can just wait? But it just like it means that people who took the plunge on the late 90s were able to do the computational power or computational problem if my strategy was just to wait until I can do it on my laptop, I'm kind of 20 years behind. So it's the same applies here. So I mean, if it's of course the hyperscalers will have the money and the power and the capability of having the biggest, and the Chinese government will have the all the capabilities of having always the kind of 20 years ahead in a way.
Yeah, I was thinking about how they went to the moon with the same computational power as modern calculator.
Well, the orbitational, orbit, it's just like a classical mechanics that you need. So it's not that, I mean, it could have been done I mean, they build a atomic bomb with just like a human computer. So they're like doing like a manual analog computation, and it's just like depends on the problem you want to solve. So it is a big, I mean, depends what you need. But I mean, the most computational power hungry thing at the moment is definitely the training these networks at the moment. So that's why the big tech giants are building big data centers for not only storing data but also like analyzing it all the time. And yeah, so it's a golden age for supercomputing service provider and vendors, but it has its kind of a societal impacts, and what we basically just like know as an citizens is the kind of what are the capabilities of these technologies, what can you do, what can't you do, and how should you behave just in a how much data of yourself you expose, and how much privacy you want to sacrifice for usability and so on. But I mean, this free of charge of using things as Google does, there of course it's not free of charge. They are they are having expenses of like hundreds of billions per year, so they need to cover it by somehow. And of course, the sort of saddest stories are the Cambridge Analytica style experiments where human behavior was understood so well that you can influence the outcome of an election by just like a feeding on a social media feeds are tailored for. So I mean, if you just like a behavior, so if you get all your news from Facebook and Twitter, probably you are being influenced by algorithms. I mean, just like I'm watching my news from Yle still, just having the evening news and Yle.fi and just I'm not active anywhere in the social media just because, yeah.
Wasn't there a recent leak about, I think it was either Google or Twitter having an internal meeting, high-level meeting, where they just straight up said they will influence the 2020 presidential elections in America.
Okay, I haven't heard of that, but I don't doubt the second that it shouldn't. Because power. Well, just like a human urges. What do you want? Well, quite many people answer power. So I mean, if you have it's kind of a word in your fingertips, so it's hard to say no. Okay, that's it. Did I have anything in mind here? Okay, so I have a few more slides before some before the discussion I meant. So one thing is to remember with machine learning is just like a nonlinear regression. So it's finding basically just like a function fitting or curve fitting to a data. So if you done your least squares fit on your some first year university classes, it's just not much more. So it's finding a function of a data. So basically, if it's not on a data, it won't be on your method. And even the best image recognition network, methods have they kind of zones of comfort. So it's very good on recognizing things. So if it's trained for this. But if a human can say that if it's just like a manipulate, so it's just like a take a scooter and just like a Photoshop it for some bizarre rotation. So I can see this is just like a fire truck put in a weird angles. But the best image recognition algorithms immediately go haywire in there. So because it's not trained for a situation where the scooter is in a air. So this applies to all the machine learning methods at the moment. So basically it's if it's not on a data, it won't be on the network. It's you can train a basically network for a single mapping. But there's some kind of a recent or kind of a current research on this is to how could I train networks that could do several things within the same network somehow. But basically, if you train a network for image recognition, it can't be doing anything else. Sure.
Do we know why they understand this? Like, if you take the...
So why a human understands it?
Yeah, why I know that it's a school bus in the rightmost image.
Yeah. I'm no neuroscientist. Does anybody else know? It's a good question, but I don't know answer to this. So probably it's a good and important question. So whether basically it comes down to a question whether it could be possible or just like putting a bigger and bigger network if I could just like understand, because it's definitely not inference. I haven't seen ever like a scooter in the air.
Yeah.
But somehow I can make just like a concept of this. I don't know the answer. It's a good question, but I don't know. Okay, so the remarks here is that so the AI, as we talk about today, is an umbrella of computer algorithms that implement something that looks like a human intelligence. So there's no bottom-up approach that we could build up something and then it would become intelligent. But we do implement this kind of behavior of something that resembles human intelligence. It's incredible how much has been happening over the last course of 3 years. For all fields of science, it's hype. Everyday life, how much there's a kind of a new applications on by these tech giants. How much things this small devices can do, even on the under the hood we don't even see it. And including this kind of like a science fiction sounding ones, like the universal translator is not very far as a technology. So the Star Trek, where they like understand everything because it's just like easier to make a series where everybody can speak English. So then just like start developing a new language for every single species they came across. But the voice, the kind of a speech to text is so advanced. The machine translation is so advanced, and the text to speech is so advanced that it's not far away where we can put it in the single device, and really can sort of just like talk in a phone. Other person talks Chinese and I can talk English or Finnish. I hear Finnish from the other end and I talk Finnish and he or she hears Chinese. So that's not very far away in the future. I wouldn't be surprised if we get it on the market in a very recent or very near future. And also even if we want to do the sci-fi thing, so this we can do training even without having anything on Y. So it's unsupervised learning. So basically encountering species that we don't understand. In Star Trek, it's cool that because the computer learns it like analyzes the language of this new species they encounter, and then they, again in a matter of seconds they can speak English. Or they hear English from the. But also this basically is possible with the machine learning technique of today of not even having the big pool of Chinese as a training set, but just like finding a new language on find a new population from somewhere in the Amazon and try to talk to them and with this universal translator it's just like get that picture what they try to say, because its idea is that the networks can find correlations that we don't understand as humans. So it's just like there's a common origin for all human languages, more or less. So the correlations are there for concepts, and even if they have been diverged over the course of years. So these kind of technologies are being expected. But the important to realize is that these algorithms are really much limited to their domain and how and with what kind of a data they are being trained. And if you know this Kahneman concept of this thinking fast and slow, so where the fast thinking is this kind of an instinct, intuitive thinking that we have made a decision and then before we have even sort of realized it. So the machine learning is much closer to this fast thinking, to the intuitive thinking, than really reasoning. So, like thinking stuff through. So basically, those AIs, as we know, they cannot reason, but they're pretty good on this kind of an inference or intuitive things. So perhaps in terms of Dungeons & Dragons, it's a very low int but a high wisdom. So if this stats are something there, an AI that would have understand it's an AI, so have this kind of self-consciousness is a science fiction and probably impossible to actualize with machine learning. Well, I don't know where sort of if you train it, if you kind of understand where, if you have the data on thinking and train it hard enough and it sort of behaves like it would be understanding each other. So how do you judge? I don't know, but I think it's safe to say that this kind of Skynet style accidents won't happen in a way that some machine like the best AI would get its own will in a way and try to do stuff. Of course, if you train and you can kind of train an AI to do decisions, and you can train it to do evil decisions and kind of sinister decisions. You can train an AI for sinister purposes, but it's just that you try to do something and then it's like a goes like out of control. That's something that's not, to my limited understanding, is not possible by the construction of this method. So perhaps if you would like to have this kind of sentient AI, it would be something like this kind of bottom-up approach where you start simulating a brain. So you put billions of neurons and make them communicate each other, and hope this could kind of emerge of some kind of an sentience out of it. It was promised in this human brain project that was funded by European Commission by 1 billion euro back in 2013, but it was just like a fiasco. It was just like scam. So that nothing useful haven't come out of the HPP yet, and nothing useful will come out of it during the remainder of duration. So that at least that didn't happen via this vision of the HPP. But yeah, any further questions, comments here?
So the evil AI would be like when the Russians try to teach the dogs to go under tanks and explode.
Yes. So you can or yeah, all kind of war animals or whatnot, or what ISIS does for kids. So yes, you can train AI to do sinister stuff. No problem there.
Like you train it to do something, but it does it in such a way that you didn't expect it to.
Sure, of course.
The Russian bomb dogs went for the Russian.
Yeah. Okay. Okay. So that one I didn't know, but yes, of course, yes. It's possible that you try to train it for a purpose, and it does something else, because it's really the hidden layers are hidden, called hidden for a reason. We really don't understand what does a trained neural network do. So it's black box basically. We know the output, we know the input, but we don't understand really on a trained network what's happening really within a network. So yes, you can do this kind of a stuff that you try to train an AI for a purpose, and then something else happens. But what I meant with this sentient AI is that it develops a kind of an urge of self-survival, or just like tries to make its own schemes on something. But of course, things can go out of control. I'm not saying that it's possible. It was this kind of a trivial example was this racist Microsoft Twitter bot. But I just, of course, internet trolls realized pretty fast how to screw it up. So, yeah.
So if I have like 30 years of life, I can hope to dream that one day I can train my phone for sinister purposes.
You can train your phone for. You can use. Yes, you can. Yes. Yeah. I mean, yeah, sure.
What about scenarios where the input of data is incomplete or erroneous, like the paperclip problem or the Great Q scenario, where we give AI instructions to make as many paperclips as possible, and then it decides that, well, buildings are good source for making paperclips, or humans are good source for making paperclips.
Yes, yeah, of course. All those things are sort of possible and a part of the kind of an ethical and societal considerations. How do we use AI? So it's all dependent on the data and the hidden correlations within the data and the biases within the data. How do we select the training set? So that's what we get out. Also, it's the outcome depends on the selected method even. So the network that we try to train. So it's a. I'm not saying it's not. The field is full of ethical and societal questions and dangers here. But like from a story point of view, the kind of sentient AIs are something that we probably gonna see.
Kind of commenting to the paperclip thing and also to the reasoning versus intuition. Like, you're not a neuroscientist, but can you comment on like what's the difference between reasoning and intuition? I mean, like, why couldn't or could an AI anticipate kind of that humans try to at some point stop this paperclip factory, and maybe I should set up turrets to defend it and kind of do that kind of.
I don't think I don't think it's can emerge from the setup of if it's really built for or made for making paperclips. You can do errors on what is a good material for the paperclip. It's the screw ups may occur there, but it's unlikely the data trained for the network can contain a concept of self survival instinct in a way.
Okay, I was thinking more from the fiction point of view here.
Yeah, sure. I mean that's pretty nicely. So we've been now with this boring reality things. So let's talk about file for as stay in a fiction, because it's typically more interesting than our maximally boring universe. So just some examples from as big computers as story elements. Just well, I'm a bit illiterate, and in our family, my wife does the reading part, and I'm more gaming side. So just some kind of a classical examples where a computer has been used as a nice story element is, of course, Star Trek everybody knows. So the ship's computer and is an important character in a way, and the holodeck as a kind of an augmented / virtual reality has an important story element for many episodes. Of course, the HAL in the Space Odyssey of 2001 is an archetypical example of how to use nicely a big computer as a story. The whole matrix where the virtual or this kind of an virtual reality is not just a spice, but it's really the whole setting is a good example of everybody living in a simulation. And from the AI gone bad is of course the Skynet within the Terminator continuum. Anybody wants to continue here? Any good pieces I'm missing?
Well, it's always on TV, but I've noticed that recently in many science fiction games there have been these AI helpers for characters who have been learning the characters' behavior or the characters' lives. So, for example, in Infinity and Eclipse, they both have this kind of thing.
Yep.
They are getting quite common.
Yep. And it's a good story element for role-playing games too. Having this kind of fun. And I think this in many games they are really learning from how the player plays the game. So it employs this kind of reinforced learning. So it is in fact a real AI assistant. So it just learns what the player is doing within a game. Any other good computers or yeah, it's on the next page. So from the literature, of course, it was the multivac system had a big role already in the mid 50s, where the computers were really kind of perhaps inspired by this first big installations in Soviet Union and whatever was published in either of those, or just like a imagination of his own. And of course, the archetypical one is the deep thought and the Earth for solving the problem of everything, for making just a big simulation, kind of a very big data analysis question. Also, the AIs have been used in fiction from the 80s. So the Neuromancer and the Wintemute in Neuromancer and these very highly autonomous ships in the Culture series of Iron Banks. But like I said, I'm a bit illiterate in terms of science fiction. So if there's anything, something that people should know on other book series or books, or should definitely add here. Okay, just a food for thought. So the kind of point was also to discuss as how could we employ these games in our games. So just like a random ideas from your games, or you have been using, or you have seen cool storylines or story arcs that has, but it's just like some ideas that I drew out from my sleeve. So the cool NPC would be an sentient AI. I don't know if people practice even know it's an AI or not. So it can be an opponent, ally, gray eminence, and also gives a good platform for giving dilemmas on human and non-human rights. So when an AI is something that needs to be protected, for instance. Also gives an technological spice for this kind of fun Stormbringer style devices for that's containing an AI with its own purposes. It could be a pretty cool gadget as in a sci-fi game. I didn't talk about much on virtual reality or augmented reality, but it's of course part of this same kind of an umbrella. So you need computational power, you need intelligence on making it happening. So it's just like as a spice, as a now and then or something, or as a whole setting. So I mean, this could be a really cool story element for a role-playing game. Also, kind of a more boring slash this kind of fun hard sci-fi things is that of course taking something that we do in reality we do with our supercomputers. And just like add a bit more drama around it. So what happens if we find evidence of alien intelligence when we analyze the telescope data? What happens if we find out on our, because we are simulating the near Earth orbit asteroids all the time with supercomputers. So what happens if we know that okay, some of this is gonna hit us in a 72 hours? We do design new drugs, chemicals, toxins, whatnot on a daily basis around the world in computers. So what if we find something, so make a major breakthrough, and so what do we do with this data? So can we develop a story around this kind of one? The pandemics are being simulated on a supercomputers. So just like having the information out of how something is spreading, zombie pandemic or something is being spreading could be a story element. And of course, everything relates to hacking and cybersecurity, privacy, and so on. Is around good themes. Starting from there.
As a story element, this is maybe a little bit on the side of the hard science fiction, pardon for that. But is there any salient hard problems in your field that we could write into history of our future AI? So this kind of technological or logical breakthroughs coming through that we can drop in as a name dropping in the history.
If I got it right, so like problems as of today not solved, and you would like to drop it in a that it has been solved.
Kind of, yeah. Like a Fermat's last theorem.
Yes. From the supercomputing, so kind of things we would like to currently establish, or kind of holy grails of supercomputer simulation that we would like to get solved is fusion plasma on a fusion reactor. It's something that's we understand physics very well. It's an engineering problem, but engineering problem that needs like a very big simulation, computer simulation to really build like a reactor that can contain it. So understanding the muddy plasma of a fusion reactor is a good one. Also, making this kind of a numerical Earth, so having like a fully coupled Earth simulation with a sufficient small grid, is that we understand really how land mass is coupled to our oceans to atmosphere, and so just get this kind of a numerical Earth model is something that's beyond the current computers and beyond the next generation of computers. But it's kind of we know what we should be doing, but we just don't have the enough computational capability.
Would it be like this capability? Would it be just on the power or the number of numbers?
Yeah, it's number of numbers basically problem. So we know what we want to do, but we don't have a computer that can do. So numerical Earth is a good one.
To comment on that, problems from biophysics, like realistic simulations of the cell membrane or even the cell or something like that, they are really difficult. And realistic models of that solve a lot of problems. And they are in the same category in the we know what to do, but there's just not enough power.
Timo wanted to say something.
Yeah, I was thinking that now everybody's building these new supercomputers, and it's the easiest when you want computational power. You can just build more. So the resources you need time and you need workforce and so on. But what if there would be some kind of resource that's limited?
No, basically, we even with an unlimited budget, so it's a limitation how much we can kind of put together, because it's not well for anything non-trivial. So the idea is that of course we can stack up the MacBook processor stack, but it won't make the numerical Earth, because we have to combine these CPUs together. So it's also this the interconnect of these things and how to package this. So it's not I mean, if you've seen the Google machine halls with this kind of endless rows of servers, so those are not very good supercomputers. So Chinese hyperscalers do list their systems on the top 500 just to get the Chinese share up on there, but they are somewhere on the 400, 500, so they're towards the bottom of the list. So the real kind of top-notch supercomputers are real supercomputers and not the hyperscaler ones. So it's not just like putting more and more racks. So there's the key issue is to make them to work together. So there's limitations on how much we can harness this power into a one computation. So it's not only a resource problem, but it's a really kind of fun technical and scientific problem. Software problem.
From a story point of view, would it be interesting to make the existing facilities like the resources that people are after? So then situation would turn so that we have these tech giants in the near future, and they have built all they can build, and now they have this like certain amount of computational power, and there's conflict because they start to fight on the computational power, and it would be maybe interesting to, from a role-playing game point of view, that you would fight over these like really cool facilities.
Yeah, why not? Yeah.
And also, I was thinking, has there been any like problems, like, because this must be quite vulnerable, these supercomputers or these facilities. So have there been any incidents in real life?
Not like a physical ones, I don't think, but of course they are current all the time. They are under like a cyber security threat. So of course these machines are tried to be breached all the time. So. Yeah, well, we are 200 kilometers away from Russian border for the Lumi system. So let's see if it becomes interesting enough.
Nice, fascinating. It would be a shame if something happened.
Yeah.
How easy would it be for someone hostile to take use of, if they manage to capture a facility like that? How easy it would be for them to add their computational power to their own, like, if it's a resource to be bought over? Easy.
You just you only need to get an account to the system. So I mean, so you can capture a system in a multiple fashion and start using it. So I mean, you don't even have to put your soldiers around it. So you can do it on the internet already.
Or just grab a guy who works there and make it for you.
For instance.
if you need to put a problem for the players that they need a supercomputer to solve, how long would be like realistic amount of time they need to access the system?
Depends on the problem they want to do. So I mean, well, it's capable of doing a limited amount of operations per second, and of course, it's you kind of more you get done by.
So like if they need to make a new kind of like drug or something, like or modify existing.
Well, it depends how hard sci-fi or how much you want to balance between the between the reality and the story. But I mean, you can sort of it's about this kind of screening. So you like a test of multiple compounds, how they dock in a protein. So one computation is not that long at the end of the day. But I mean, you have to just like a farms, run like a. The point is to use supercomputers. You just get sampling, enough sampling out of it. So I mean, you can design a new drug in a matter of day running the computations. But of course, the real like a research project for finding a new drug that would do something designed. I know a protein I want to block, so it's like may take 3 years to run the computer simulations over when you find like a suitable molecule that docks in a correct position in a molecule. So it's just about what you want to do a story. So if you log in and start magically driving something, you get a lot of stuff done. But I mean, you have to know what you want to do.
Do you have any examples of this lengths of time, something that has been done recently? Something.
So basically, the point is that the computers are full all the time. So it's shared among many users. They are 100% loaded, every single system everywhere in the world. So scientists do get they have questions to get them full all the time. And typically you get only like a fixed like a portion of the machine at a time. So in a machine of couple of thousand of nodes, you just like get some hundreds of nodes at the same time. So and that this kind of an full machine runs are less well. They have their kind of a show-off value, but and those things are kind of this sort of a narrow amount of questions where you can really harness the whole system for something. And for those runs where you really need the whole system, typically it's given for a user for 24 hours or something like this.
More like, do you know real-world examples of what has been done and how long did it take for a supercomputer?
Well, there's for just like one the recent one was for you. There was just recent earthquake in California just some weeks ago. So they wanted to understand what happened. So they used the like a Summit sister system Sierra, which is in Lawrence Livermore, very close in fact to the place where it is. So they run a very kind of an biggest earthquake simulation for done ever to really understand the geophysics on the Californian. So they basically, I think they had the codes ready and something that's like I wanted to increase the just put a denser mesh and so on. So they done it in terms of a couple of days to run this kind of like a state of the art geophysical simulation of this earthquake. What really did happen on this Californian earthquake. And that was using the whole Sierra system for they gave it for the researcher for several days for doing it. And from our systems, the most accurate space weather, so what happens around the Earth, so when the solar wind comes in, so that's in fact a model from University of Helsinki. So we gave the SISU system that was just taken down. We gave like 5 years ago. We gave it for the research group for a couple of days to really run this, and they've been that was kind of a breakthrough for this group. So they have the most accurate simulation of what happens on the magnetosphere around the Earth. So we gave the whole system for them to run those codes. Yeah.
is there kind of a system of scheduling or partitioning space or time to use a supercomputer?
Yes.
I think it's
yes, it's a kind of a queuing system. So you submit just stuff on a queue, and then it goes to the execution on the like a one by one.
So it depends on basically if it's available for
you just like a queue.
Yeah.
You put stuff on a queue, and then it goes to the execution.
On a more speculative note, can artificial intelligence be taught, like to make people more intelligent, teach people to think?
Sure, I think it's the educational usage of these methods is a big thing, and most of the I think good things. I mean, it's not perhaps up to date on the what happening, but it's a big buzz on this kind of educational technology on trying to use this kind of human behavior modeling on that one. But I don't have any good examples in the top of my head. Okay, any other questions, ideas, comments?
How long is the queue usually? Like if I apply for time to do a calculation, how long would I need to wait for it to be completed?
Depends on how big portion of the system you want to employ at the same time. So the small jobs can go through almost immediately, and then for the large ones you need to wait for some hours or some days.
Okay, but within weeks?
Clearly, yeah. I mean, I don't think we ever seen more than. I think the typical kind of if you're just submitting jobs, and then it's all the time running, and then you put a barrier to the queue and see how fast the machine is trained. So I think goes empty in a few days. So maybe it's a.
Is there any kind of a gatekeeper on the queue? So who decides who can put stuff on the queue?
Basically, everybody can submit, and the queuing it's like an NP HUD. The problem on the prioritizing and placing the jobs. So there's a lot of logic and even like an AI accelerated logic on the queuing system. And but it of course can be adjusted by human interference. So basically, if there's somebody wants to somebody has a hard deadline on a conference poster or want to submit some kind of an hero run for a reason X, we can just pause the other jobs or train the machine, and so we can just buy a human approval on staff members. Okay, so thank you for discussion. So I think we could stop here. So if you have any further thoughts, you would like to get correspondence, so this is my email address, and like I said, I am pretty skeptical on social media, but sometimes I tweet something on Twitter, so it's on the and follow something mostly professional on the Twitter, so Pekka Manninen at Twitter. Okay, thank you everybody.